So the title of my talk today is Key Drivers of Household Water Use in South Australia and the practical implications from that. This was part of a Goyder Institute project, the Optimal Water Resource Mix. Just like to acknowledge the efforts of the team that was involved, including people from the University of Adelaide, CSIRO and also SA Water played a big role in getting this project off the ground. The motivation for this work is that predicting future water use is not straightforward. This graph shows the decrease in water use over the last couple of years. I'll just put up my pointer here. It's going to work. Okay, so the question is, it's gone down over this couple of years. What's going to happen in the future? Is it going to go up, rebound, because this has gone down because of water restrictions? Is it going to stay static, or is it going to continue to drop down because we've seen increases in efficiency? The other motivation for a bigger understanding of household water use is for things like integrated urban water management. As Baden talked about, when you put a rainwater tank in, you take some of the water use off the home from the rainwater tank. So to assess the effectiveness of that, you need to have an understanding of how the water is used within the home, whether the water is used for outdoor, shower, toilets or taps. And then you can assess things like alternative water supply, such as grey water use and rainwater tanks. Now, and the other motivation for the talk is that a lot of the changes we're looking at in water use happen at the household scale. If you put it in a shower head or rainwater tank, they're looking at changes at people's household scale. And the key question is, how does that transcend to the larger scale, the region, the city? How does it affect your drought security overall? That's a big challenge. So the objective of our study was to evaluate the key behavioural drivers of household water use. And our approach to this was that we selected representative of about 150 study households in the Adelaide area. We installed smart meters on their house. Now these measures are about every 14 millilitres at 10-second intervals, so they're really high resolution. We combined that with a household survey of the people's attitudes and behaviour. We did an audit of their water using appliances. We self-reported water diary to get an understanding of how they use water within the house. And because we took this high resolution data, we're actually able to then understand and do flow trace analysis to understand, well, what are people using for showers? What are people using for outdoor? What are people using for toilets overall? Okay, and that gives us an idea of the percentage of these various water use within each house. What we then do is we looked at how these water use changes as a function of people's behaviour and their appliances to understand how we can build a predictive model of the household water use that takes into account behaviour and the appliances. Here is the suburbs that we had the houses for the study. We estimated we represented about 65% of houses in our metropolitan Adelaide area. We compared income, family composition, appliance proportion, the occupancy of the dwelling structure to get that estimate. We only looked at owner occupied separate houses. We didn't look at renters because we wanted people who are going to be stable in the household. And unrepresented in the study were single parent families, renters, people in units, and newer housing stock. We only had 150 houses, funding for 150 houses, that's limitations of the study. And that's because most of the study, most Adelaide is fairly old houses anyway. Okay, so this is a plot of the water use for each of the different end uses, the toilet, washing machine, shower, dishwasher, bath, for the 150 houses that we've got here. As you can see, there's a significant variability between the houses overall. Some were down about 100 litres per person per day, some up around 250 litres per person per day. The average is about 135 litres per person per day, with the biggest use being the shower, The next biggest use being the tap, and washing machine and toilet pretty similar. These averages are interesting, but I think the more interesting thing is the big variability between the houses. If you guys have a look at the top two houses here, you can see that there is the biggest water use for the top house is the washing machine, which is big here, and then the next one down, the biggest water use is your shower. So there's a big difference between houses overall in the way they use water. Now, when part of the survey, we asked the houses, well, what do you think your proportions are of the various end uses? And when we compared that against what we actually estimated based on the water use analysis, and what we found is that households are not very good at predicting their own indoor water use and how they use water within the house. This is the relationship here between this is what people actually used for washing machines, this is what people thought they used. This motivates that people really need greater information to understand, well, how they're going to save water. If they don't know in their house how they use water, they won't be able to know how to save water. When we looked at the different appliances, we looked at more efficient shower heads, more efficient toilets. We found that front-loading washing machines offer the biggest water-saving potential. We're looking at, currently we're sitting at about uptake of about half of the houses. About half the houses have some sort of water-efficient appliances. And if we look at the potential savings, we can see if everyone moved towards water-efficient appliances, we're looking at saving about almost 20 litres per person per day. What we found, and most of that comes from your washing machine, that's your front loader there. About half of that comes from the washing machine. What we found, one of the things in literature is, do people change their behaviour when they put in, because I've got a water efficient shower head, I can take longer showers. We found that there was no evidence to support the hypothesis, so there's no behavioural difference in terms of frequency and duration with water efficient showers. So the conclusion there is that schemes that encourage the uptake of water efficient appliances should be encouraged. Another thing we found, because we're able to understand people's socioeconomics and house composition, we found there was this distinct household types that we found overall. So which had different water use and different sorts of behaviours. This compares the average water use for all households, and then we split the households in two different groups. One was a group which you might call the pensioner group, which only had adults in there, 55 plus, and the other group was a high income with a family, so that might have 3 or 4 people in there. There's a big difference here in terms of the water use. You can see for a high income family, they've got a lot higher shower use than average, but much lower washing machine use than average. We asked them about their attitude to water conservers, and we found that they really don't think they're going to be water conservers in these households, and that's indicated by their high shower use. But overall, so they had high shower use, but overall their indoor use was actually lower than the average. Because they had a high income, they were able to afford to buy a water efficient washing machine. Okay? So you have much lower water use overall. So for these households, if you're interested in water savings, they should target their shower use, okay, to try to reduce their shower duration. Now the other group is the adults 55 plus overall. Now this group had a lot lower shower use than the average and the high income family, but they had a lot higher washing machine use than the than the average. And they also had a lot higher toilet use as well. Now, overall, these people thought they were water conservers. They thought, well, I'm a water conserver, okay? And you can see it because they took shorter showers. But their overall water use, these people who thought they were water conservers, was higher than average, and that was because of their high washing machine and toilet use. Now, the washing machine use is related to the uptake of water efficient in these adults 55 plus, the uptake of water efficient appliances was about half of the average. And also for high toilet use, there's a high toilet frequency. These people are home more often, so they use the toilet more often at home. We found there was a strong seasonal impact on water use, which is probably no surprise, but we're able to quantify it. In winter, you're looking at about 153 litres per person per day. That jumps up to about 500 litres per person per day. Based on the limited data set we had, it was about 40% of the total household water use overall. This was a big, very hot summer that summer there. So, again, with the seasonal in-use, we found that households weren't very good at predicting their seasonal water use. This includes things like outdoor and evaporative air conditioners. You can see that was the estimated, and that was the actual perceived use. So, again, to understand water, how to save water, people need more information to be able to identify what's the most cost-effective water-saving opportunity. There were a lot of drivers in the water use between households. We looked at the effect of property area, income, and the age of the households. Larger properties increase use by about 25%. Lower income increases the seasonal use by about 20%, so people with lower income use less water seasonally. And adults 55 plus also have an increased use. We attribute to that because people are at home more often, so they probably garden more often. This strong variability in drivers means we need to think about really taking a targeted approach to design of water management systems. The peak water use was given here about 2.8 overall. And this is another thing we found was that when we looked at what houses contribute to the peak, what we actually found was that only 20% of the households contribute, or 20% of households contribute to 50% of the peak flow volumes. So if you're interested in reducing your peak demands, you only have to target 20% of the houses. You don't have to target everyone. That provides opportunity then to reduce peak demands by targeting these high peak households. Okay, Grace will tell you I've got a couple of minutes left. What we did, I'll go over this, we actually used this information to build in a model to be able to predict the water use into the future. This model was developed as part of eWater CRC. What we found was that the model did pretty well once we included all the data. So we're getting errors of the order of 5% overall. Very reliable end-use predictions. What we found is that we couldn't use the data from interstate. If we used data from interstate, we got fairly high errors of the order of 20%, although 20 up to 50% overall. So it's important to have local information. We estimated that the decrease in water during the drought, there was about a 15% decrease in water use. Most of that half of that could be attributed to water efficient appliances, and half of that to a decrease in the outdoor water use overall. So there's a question now, will that occur into the future, that post-drought demand, or will it bounce back? We use this to predict the response in the future overall, what's going to happen in, say, 20 years' time. We looked at a couple of different scenarios, and we found that the uptake, if you get 100%, currently now, if you get 100% uptake of water use, looking about a reduction of about 7% in terms of the household demand, and about 11% in the overall demand volumes. This only looks at increasing uptake of water efficient appliances. It doesn't include any changes in behaviour. There's a lot of research that's been done around people changing their behaviour, decreasing shower use and things, but we didn't have time to test that in this study. Okay, so in summary, we identify the key drivers of household water use in Adelaide. Smart metering analysis and surveys. This is the first time it's been done in Adelaide. We identify some practical opportunities for more targeted approaches for water system design and management, aims to reduce water use and reduce water use costs. In terms of future research, we'd like to continue the monitoring of these houses because you only got one summer. The seasonal water use makes up about 40%, and also it's very strongly dependent on climate. And we'd like to look at opportunities for more targeted approaches to reduce demand. Seems every household is different, but we saw some groupings there. I think obviously for some targeted approaches in the future. Thank you very much.